In today's lesson, we'll be learning how to graph with transformations. There is a general strategy that you should use when you're graphing a quadratic relation in vertex form. Your very first step is to graph the base parabola, which is y equals x to the power of 2. Next, you want to apply transformations related to the a value. If you recall, a determined if the parabola was opening upwards or opening downwards. In other words, whether it is being reflected in the x-axis. And it also determines if there is a vertical stretch or a vertical compression. Afterwards, you want to apply transformations related to the k value. If you recall, the k value determines if the parabola is translating up or translating down. And finally, you want to apply transformations related to the h value. And if you recall, the h value tells you if you are translating to the right or translating to the left. And at the very bottom, you can see that there is a small note that step 3 and 4 can be done in any order, or they can be done together. In our first example, we have a quadratic relation in vertex form. You want to begin by analyzing the values of a, h, and k. In this quadratic relation, the a value is -2. The h value is -5, and the k value is +3. It's important you include the signs in your analysis. Let's begin by looking at the a value. Since the a value is negative, that means it is reflected in the x-axis. In other words, it is opening downwards now, so it is frowning. The value of 2 means that there is a vertical stretch by a factor of 2. In other words, the parabola is going to become more narrow. Next, we're going to analyze the h value. Remember, the h value is counterintuitive, which means the -5 is a translation to the right. So I'm going to say translate 5 units to the right. Last but not least, we're going to analyze the k value. The k value is +3, which means you're going to translate 3 units up. As you can see, interpreting the meanings of these different values is very important before we start graphing. We're going to begin with our base parabola before we do any transformations. So I have a table of values, and you want to determine the y values for these given values of x. That should be pretty simple. You're going to substitute these values of x over here, and you're going to solve for y. So -3 squared is +9, -2 squared is +4, -1 squared is +1, 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. At this point, you can go ahead and graph these points or coordinates, and you should get a nice parabola. As you can see, I've already graphed y equals x2 in Desmos, and it has given us a nice parabola. If I were to do this by hand, these are the different points you would plot and then connect with a smooth line. All I've done in this slide is just zoom out on my previous slide. At this point, we're going to apply the transformations related to the value of a. Remember, we determined that the meaning of this value was, we're going to reflect the parabola in the x-axis. Moreover, there is going to be a vertical stretch by a factor of 2. Reflecting the parabola in the x-axis and completing a vertical stretch by a factor of 2 only affects the y values of these coordinates. So mathematically, all you're going to do is multiply these y values by that value of a, which is -2. Let's do the work for that. So I have 9 multiplied by -2. That is going to be -18. I'm going to multiply +4 by -2. That's going to be -8. I'm going to multiply +1 by -2. That's going to be equal to -2. I'm going to multiply 0 by -2. That's going to give me 0. I'm going to multiply +1 by -2. That's going to give me -2. I'm going to multiply +4 by -2. That's going to give me -8. And I'm going to multiply +9 by -2. And that is equal to -18. And there we have a whole new set of y values, and you can take the existing x values and plot these points. These are the x and y values that I'm referring to, by the way. You can see the base parabola of y equals x squared over here, and down below you'll see a blue parabola, and this is the parabola that has been transformed. So it has been reflected in the x-axis. Moreover, it has experienced a vertical stretch by a factor of 2. And that should make sense because when you reflect something in the x-axis, it's no longer going to be opening upwards, it's going to be opening downwards. And if you're going to vertically stretch something, it should be more narrow, and it does appear to be more narrow than the base parabola. Next, we're going to take a look at the value of k, which was +3. Earlier, we determined that this meant there was a translation of 3 units upwards. So I'm going to make a little note here. Translate 3 units upwards. When you move a parabola either up or down, that only affects the values of y, okay? But don't forget, we've already applied a transformation, so the y values have changed already, and now we're going to change them once again. So when we move a parabola upwards, all of the y values get more positive, and when they get more positive, that means we add 3. So I'm going to take 18 and I'm going to add 3, which is going to be equal to -15. -8 plus 3 is -5. -2 plus 3 is +1. 0 plus 3 is 3. -2 plus 3 is equal to 1. -8 plus 3 is equal to -5. And -18 plus 3 is equal to -15. And there we have a whole new set of y values, and we have our existing x values that we can use to plot these points. These are the x values and the y values that I'm referring to, by the way. Here you can see our base parabola in red, that is y equals x to the power of 2. Our blue parabola represented a reflection in the x-axis as well as a vertical stretch by a factor of 2. And the orange parabola, which is new, represents a translation of 3 units upwards. And I'm going to make a little note of that. Translate 3 units upwards. Our last transformation involves the value of h, which is -5 in this case. Remember, the value of h is very counterintuitive. When you think of -5, most people think you're moving to the left. However, it is the opposite. You're actually translating 5 units to the right. So let's make a little note of that. Translate 5 units right. When you're moving a parabola left or right, you're changing the values of x. But if you're translating 5 units to the right, all your values of x are going to get more positive. And what I mean by more positive, that means we're going to add 5 to each of our values of x. So let's go ahead and do that. -3 plus 5 is 2. -2 plus 5 is 3. -1 plus 5 is 4. 0 plus 5 is 5. 1 plus 5 is 6. 2 plus 5 is 7. And 3 plus 5 is 8. So what you can do is you can use your new values of x as well as your existing values of y. You can plot these points and transform your parabola. You can see that we started with our base parabola of y equals x squared, the red parabola. We reflected it in the x-axis and we applied a vertical stretch by a factor of 2, and that gave us our blue parabola. Next, we translated our parabola 3 units upwards, which gave us our orange parabola, and last but not least, we translated our orange parabola 3 units, or I should say 5 units to the right, which gave us our purple parabola. So let's make a little note of that. Translate 5 units to the right. Let's recap what we just did. We started with our base parabola of y equals x squared, which gave us a table of values. Then we applied our transformations related to a. Then we applied our transformations related to k. And last but not least, we applied our transformations related to h. And just remember, h is very counterintuitive, so you have to be super cautious when dealing with that transformation. Let's summarize everything we've just done. So we started with our red parabola, which was y equals x squared. We applied a reflection in the x-axis, and we applied a vertical stretch by a factor of 2, which gave us our blue parabola. Then we translated our blue parabola upwards by 3 units, which gave us our orange parabola. And then we translated our orange parabola 5 units to the right, which gave us our final purple parabola.